Welcome back to the Astro Dude YouTube channel. I get asked a lot, hey Mitch, I know you have your camera, your hypercam, and I'm having a hard time with what the exposure, like what exposure should I use? Because I'm shooting the horse head tonight with my refractor. And I'm like, okay. Well, it's kind of hard to answer that question. Like basically what my friend was saying is how much gain should I use and how much black level or offset? And maybe how long should I expose it? Like for the horse head, should it be like 1 minute, 5 minutes, 10 minutes? It would be nice if we could have a way to determine the exposure properly so that every time we go out and shoot in a dark sky or even a light polluted sky and we shoot a DSO, we could have some way to tell us what the proper exposure, gain, offset levels are. And guess what? There is. It's in Sharpcap 3.1 Professional right here. And let me open it up. Take a few seconds. Again, if my computer doesn't freeze up. Let's try it again. Open. I think I got it this time. Welcome to Microsoft. So Sharpcap Pro. This is version 3.15059. Okay, so Sharpcap, thanks to, I believe it's Robin Glover. Hope I got the name right. The maker of Sharpcap. If not, I have to erase this video and start over. He has an incredible tool in here called sensor analysis. So I thought I would make a video on attempting to ask the camera, it's my Altair 183M, again, close that, asks the software to run a sensor analysis and tell me what the best exposure is for any given night. So that's interesting. Let's see if I can run this little utility and learn from it. Okay, so if I understand this right, and I'm no expert at this, but you have to connect to the camera, and we are. We have the old settings from before. Don't change any of the settings. And let's open up first the histogram. Go to the top here. There's a little square with a green histogram in it. There it is right here. Okay. Now, I believe that under Tool, Sensor Analysis, you have this little box that comes up, and there's a few things it wants you to do. Now, in order to analyze the sensor sensitivity for the sky, you're going to need a source of light. And where do we get that from? Well, here we go again. Remember this? Yes, that little box does more than just do flats. It can help you to analyze your sensor, doing the same thing by putting a light on top. And as you run through the wizard for the sensor analysis for your hypercam 183 color or mono, this becomes valuable. Now at one point it'll ask you to take it off and put it back on. So let's close this and minimize that. Let's go back to our sensor analysis. Let's read a bit. This tool measures the physical electron per ADU and the read noise of your sensor. You will need constant illumination. Natural light is best, but the pad works excellent. Relatively low light level. In other words, I've turned my drafting board down to the lowest level. Very important to have an evenly illuminated area to view. Use the ASCOM driver, not direct show. Select raw mode. We are in mono 12, which is raw. And to use the high bit, in order to use the high bit depth for best results. So we have the histogram here and I've got this set for 325, just to get the light. Let's push start, and there'll be some more information coming up. Select an evenly illuminated area of the image. You see this little red square up here? So I'm going to grab it, bring it down a little bit. About 1/3 of the way. For some reason, I don't want it on the edge and I don't want it right in the center. And I'm going to make this just a little bit bigger, but not too big. Look for a histogram that is narrow and has a single peak, which we have. Select an area of at least 100 pixels on a side, so you can see it if you start from the center, go in each direction. Aim for low light levels to avoid very short exposures when testing high gains. So this is fairly low. As you see, it automatically reduced it to 8.1 milliseconds. I don't need to say much here. Follow the wizard, and let's proceed. We have a nice spike here. We're good. So next. This whole test may take 10 or 15 minutes, but I'm going to let the video run the entire time. I guess I'll talk a little bit throughout. Here it says measuring the electrons per ADU. The green crosses, here's one of them already, on the graph should form a straight line. In other words, hard top right to hard left bottom. And if you notice what's happening to exposure, it's changing. The software is analyzing each exposure, and it went probably from 5,000 down to 100. Probably from the maximum amount of exposure to the minimum. And also, it's going to change your gain from 5,000 down to 0. It's also going to change your black level. But never, never, never touch any of it. In fact, don't touch anything while the wizard's running. So look what step one's done. We have our noise squared and our mean ADU, which is represented in this graph. Don't have to try to explain it. I didn't make the software. I just want to know what my sensor will be able to choose on any given night when I rerun this, not this wizard, but the brain, which I'll show you at the end. Please cover the sensor for dark measurement. The sensor needs to be covered to allow measurement of dark frame noise level to be made. I'm waiting on you, so I'll be right back. I'm going to push the pause. Let me go take the light off and cover, make sure the telescope is under a dark condition, almost like I'm doing darks. Be right back. Okay, so I turned off all the lights, took off the drafting board, my flats panel, put on the black cap, put my big dark coat over top of the whole telescope, and let's proceed. Let's see if it can do a dark measurement. Well, as you can see, the screen just went pitch black, so that's a good sign. And we're going to let that run. That could take quite a while. Meanwhile, if we look at the exposures, if we look at the black level, now it's going from 49 to 47. Sometimes the gain will go up. First, it'll run all the black levels. Right now, it's probably going to run all the black levels, and then it's going to adjust the gain. It's going to keep increasing the gain by changing black levels, and it's recording it. And later on, you're going to see a nice, we're going to see the green X's for the mean ADU, and then you're going to see red. One will be read noise, and the other will be, the sensor analysis results, which we will look at in a bit. Dum-de-dum-de-dum, what am I going to talk about? Okay, so I have friends that have hypercams, quite a few of them, and we've had a long discussion of how can we, what's the best exposure? And I have friends that have an ASI, ZWO 1600 Pro mono, and they're shooting, oh boy, 5 minutes, 10 minutes, 15-minute subs, and yet we can get the same results with the hypercam, and we're shooting 1 minute, 45 seconds, 30 seconds, being that the Sony chip is so sensitive in the hypercam and is such low noise, being a CMOS chip, not a CCD. So I got the Horsehead Nebula within 60 seconds. In fact, while this is running, it's going to take a few seconds. Let's see if I can show you an example of IC434 using the hypercam, a tiny little refractor, and I guess I'll just pick any of them. And the hypercam, the AT72ED on the AVX mount, and 60 seconds. This is 60 seconds times, it's about an hour. So 70 times 60 seconds. That's the Horsehead Nebula. And of course, I ran various tests on brightness and the amount of color. So that's what you can get just within 60 seconds. You know, this looks like 4 or 5 hours of integration on some things I see online. Now, mind you, I didn't properly remove all the signal to noise, but actually I was looking at it for the flaming star, the nebulosity. Look at all the clusters. There's so much flux on the background. This is incredible. And again, 60 seconds, not 5-minute subs, not 10-minute subs, just 60 seconds. While we're waiting, it's still going. Okay, let me see if I can show you something else. That only took, this time let's go for, yeah, I think it's just 60 seconds. Let's look at the crab. So here's a crab nebula. Excuse me. So this time I decided, okay, on the Horsehead I did 1 hour. What if I did 300 times 60 seconds? There's the result. M1, the crab. Camera, Altair Astro hypercam. On the tiny little, this specific telescope, actually that was my C8 with the old Meade f3.3 focal reducer. You know, the one that they used to use on the Meade DSi Pro? This is the reducer that took M1. All right, let's keep going. Still got some time back, still measuring. Let's go back, and if I can show you perhaps M33. All taken with the Altair camera. One more. Let's see if we can find you M33. So this M33, just see if I can go to choose the one that is okay. So here's M33. This time I said, can you really take a picture of a galaxy at 30 seconds with a camera, with a CCD, with a CMOS? Well, I had my Altair Astro, and I said, let's try to shoot M33 and not go above 30 seconds. So I said, okay, well, how many should I shoot? I didn't know, so here's what I did. I shot 300 on Monday, 300 on Tuesday, and 300 on Wednesday for a total of 925 frames. Yeah, you heard me right. 925 subs of 40 meg each using the Altair Astro 183C color and my C8. And what was the F ratio? F3.3, because it's the Meade focal reducer. Yeah, that old clunker. And the C8, and it gave me a relative focal length of 660 millimeters. And this is bin 1x1. If I take the focal reducer out and I put the 6.3 from Celestron, then I get 1260 millimeters. Then I would have shifted over to binning 2x2 because of the arc seconds per pixel resolution, the image scale. So look at the detail in here. It's not the greatest picture, but look at the detail. Look at the internal core of M33. 900 times, 30 seconds. It took me 3 days to process this. It took 7 hours for PixInsight to calibrate the darks and the lights. I can't even remember if I had flats in there. Okay, so, hey, perfect timing. Please uncover the sensor. Uncover the sensor for gain measurement. Again, you have to let the light back in. I'll be right back. I'm going to pause this, and I'll put the little drafting board back on, my flats panel, and uncover it. Be right back. Okay, everything's back to normal. My flats panel's back on top of the telescope. Let's proceed. Measuring relative gains. So again, it's going to go through its pattern of acquiring images and analyzing the sensor for its gain and read noise and exposure time and offset. You can do this with your hypercam 183C and Sharpcap Pro. Run the color. This entire session that I'm doing now can be done both with the color and the mono. Keep in mind that the color will be a lot less sensitive only because of the Bayer matrix that's on top of the pixels. You know, the RGGB capsule, the little lenses, the red, green, green, blue, which gives you quantum efficiency, and I don't want to be quoted here, but I believe it's about 58%. Now the mono hypercam from Altair Astro, the 183M, is 84% quantum efficiency, which is 4 times as sensitive as the 183 color, which makes it a killer for faint nebulosity. So we're done. And if I'm very careful here and I grab this bar, sometimes Sharpcap tends to pull a little trick on me. I don't want to lose this. I'm going to bring it up some more. Okay, I am not going to pretend to know everything that is meant by this, because I'm not that savvy when it comes to electrons per ADU. I know the gains are from 100 up to 5,000. That's the slider here for analog gain. And it tested from 100 to 5,000, 4,009. The read noise at 100 gain, which is 0 gain, is 3.4 electrons. I have no clue what that means. It is, as you increase the gain, the read noise goes down. Okay. Again, Robin can explain this much better on the Sharpcap website. Full well, I have some idea what that means, how much light it took to fill up the pixel at 0 gain. And it was at no gain at all, it's 16,000 ADU. As you increase the gain, the full well actually drops, right? And if you're maxed out the gain, in other words, you amplify the signal through the amplifier, then it shows that there seems to be less electrons reaching the well, if that's how I understand it. And seeing that we are using a 12-bit camera and our full well is 4094, it just makes sense that your full well, and anything beyond that, you start to actually lose dynamic range. And before that, there's just not enough. But look at the gain at 400. It's 4,075 full well. I don't know what the rest of these numbers mean. The dynamic range, which are f-stops, again, look it up in Cloudy Nights. There's a huge thread on this dynamic range / full well read noise and EDU values. This is nice, and the graph says that this is the read noise. Starts from 4 or 3.5, goes right down to 1.8, and the gain is starting at, if we follow the line here, from 0 gain, which is way up here, and the gain is maxed out. And of course, it seems like the gain, as it continues to increase, the read noise drops. So here at 400, in other words, gain 400, right here, let's see, 1, 2, 400, right about here is the recommended value. So 400 gain is 4,000 ADU. All right, you can copy this to the clip, copy data to clipboard, put it in Notepad, save it for later. But even if you don't, and you should, or take a snip of it from your screen grabber and save it. But now that this has been applied and it's been saved in a log somewhere, I'm going to close this. All right? I'm going to close it. Well, hopefully I didn't break anything. Now something new just came up that was never there before when I hit the histogram. Show the histogram? There never used to be this little brain here. The reason there's a brain now is because we ran the sensor analysis tool, and now it has all kinds of information that it can use to test the sky, which is very interesting. So I'm just going to put all these settings. I'm going to put the gain back at 400. Not that it matters, but it was a recommendation. And the black level, I'm just going to start at 0. USB's at 0. and I'm just going to put it at 1 second, which doesn't make, who shoots anything at 1 second? Hey, trust me, a friend of mine shot the Orion Nebula the other night, and I suggested 5 seconds using the hypercam 183 color. Guess what? At 1 second, we burned out the core. Sorry, at 5 seconds, we burned out the core. I should have suggested 1 second, but I wasn't there. He's a good friend of mine in the United States. That is how sensitive the hypercams are, right? So keep that in mind. So let's just look at the brain for a second. Brain. Look at the brain. Smart histogram. Sky brightness. Smart histogram needs to measure your sky brightness level to calculate optimal settings. That is amazing. Point to a dark part of the sky. Alternatively, select a dark section of the sky to view. So don't choose a rich area of stars. Get somewhere there's not too many stars. Don't point it directly over a city unless you're in the city. But I think you know what it's trying to say. Be aware that your camera settings will be changed, or if you know your electrons per pixels per second of your sky value, then enter it in. Now, I'm going to wing it, but I did a few months ago, and I think I was 60. I was getting 60 electrons per pixels per second. But don't use this. Why? Because this can do a better job. So let's look at other settings. What's the minimum exposure would you like? Well, we know this camera is very, 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 very sensitive. So I'm going to say, I'd like to at least start with 10 seconds, but I don't want to go over 2 minutes, no matter what. Okay, that's fine. What is the read noise limit? Let's hover over this. How much can the read noise be allowed to contribute to the total frame noise? Well, no more than 10%. How long would you like to stack for? Well, even though this doesn't change the graph, it's how long would you like to stack? Well, in my case, I start at 8 o'clock. I'm done by 1 in the morning. So about 3 hours would be good. And what are we aiming for? Maximum dynamic range, which is very good. Or some people who are ZWO owners or QHY will use unity gain, which is midpoint of the gain value. I always shoot for maximum dynamic range for the object, regardless of the object. Now, I'm going to have to pause the video because this is not a dark sky, but I'm going to try to simulate a dark sky by covering my telescope partially and just letting the natural light in the room look like a 7 or 8 o'clock at night when the sun's gone down. I'll be right back. Okay, so I covered up the telescope partially and let a little bit of light in, but if we look at the histogram, it's really hard left. And that's okay. This is a test and we're not outside, but I think we'll get the idea. I'm just going to try, let's say, 4 seconds. Let's just see if the histogram moves a bit. Am I allowing a little bit of light in to pretend that we're outside? Yeah, we're good. So it moved a little bit. So now we've answered all these questions to the best of our ability. No less than 10 seconds, but don't go over 2 minutes. Allow 10% read noise to that you can deal with the CCD, so it's not going to put the gain too high or the exposure too long because that's read noise sensitive. Stack, I want 3 hours worth, and we're going to go for the maximum dynamic range of the target. So hit the measure button. Let's see if our new sensor analysis can read the sky, simulated sky, kitchen, and make a few adjustments. So here we go, adjusting exposure to 4.2 seconds. And the histogram's already at 28% to 45. Waiting for the image to settle down. Okay. All right. So here's the recommended suggested settings for 10 seconds. Let's say that I had chosen 10 seconds, regardless of what the target is, because what it cares about is how dark is your sky. This looks at the sky glow, sky brightness. Let's analyze a little bit of what it did. And I am not an expert on this. You want to go to Sharpcap forum and just ask lots of questions. My sky brightness simulated is 26 electrons per pixels per second. Now, in reality, here outside my backyard, it's about 65. That's fairly dark. I have an SQM of 20.05 on a good night. My friend, his is better than me. He's in the United States somewhere, and he's getting 50 electrons per pixels per second. So obviously he's going to be to expose a lot longer and go a lot farther, and its exposure times can go, up to a minute or two. Why? Because his sky is darker. The brighter the sky, the shorter the exposure, the less gain. So here's what was recommended for my settings. I said, give me 10 seconds, don't go over 2 minutes. It chose, fine, you want 10 seconds? You're going to have to shoot 1,000 frames. And the gain at 0 or 100, which actually 100 is 0 because it's completely turned off. The actual gain of the chip is 3.95 electrons per ADU. And the black setting or offset, it says to put at 0. Right now it's at 72, so back to 0. Would I do this? Well, no. Why would I want 1,000 times 10 seconds? Would it accomplish the mission? Absolutely. But I mean, that's 1,000 times 40 meg, and I don't have 10 gig or 50 gig of hard drive space. So let's tell Smart Histogram, can we run this again? I won't run it again, but can we run it? Let's try 45 seconds, no less than. But let's look also at the little graph. Here it says, if we look at the gain, it says 100. That's the recommendation. So I did put it at 100. And it says exposures 3.5 seconds maximum. Okay. This graph represents 12-bit and 8-bit. Doesn't matter if you would have used 8 or 12-bit, you would not lose dynamic range. People go, oh, you have to have 12-bit. It's a higher depth. Not at these settings. You could still have used 8-bit and there would be no change. Now, tab number 3, detection threshold simulation is at 45 seconds. At 45 seconds, you have, I'm not understanding this chart here, faintest detectable object, electrons per pixels. So I guess it's because I just changed this to 45 seconds. We should have left it at 5 seconds and would have had the other numbers. So recommended, the gain is the blue, the green, I'm colorblind. The gain is 100, have it set, and recommended 45 seconds. And of course, just by changing the minimum exposure, all these numbers changed automatically. This was 5 seconds, this was 1,000. Now, I'm only going to need 240 times 45 seconds to reach the same sky brightness that it analyzed. Of course, this is the test we ran earlier. The read noise starts to increase, or the numbers go down, as you crank the gain up to 5,000. Recommended about 400, which is right here, for excellent dynamic range. Let's go back to total exposure. So let's see now, 45 seconds. Let's try 1 minute, 60 seconds. So at gain 100, based on this dark sky of 26.8 electrons per pixels per second, as we draw in the photons, I'll only need 180, exactly 3 hours. But that's what I suggested. I wanted 60 seconds, and I wanted 3 hours of stacking time, and it says, well, that's fine, then 3 times 60 is 180. But the gain stayed at 100. Let's reanalyze it by leaving all these numbers here. Remeasure my fake sky, adjusting exposure and gain, and let it do its thing for a few seconds. Now I'm saying under 60 seconds, stay at, but don't go over 2 minutes. I don't want to increase the noise. So nothing changed. It already has all the settings inside internally. It's already measured the sensor sensitivity. So the sky is 23. The gain stays at 100. There's almost no gain has to be added to it. 1 minute and 3 times 60 is 180, which is 3 hours, which is what I recommend. I asked for 3. Again, no offset, no black level, not needed. If you increase this down here to, let's say, from 0 to, let's say, 10, it'll help you pull away from the left side of the histogram. If you're stuck there, you don't want to be stuck there. This is noise. You want to be in the nice, bright green, dark green. Anything lower, and if I hover over this, it says, consider increasing exposure because the sensor read noise will contribute significantly to the total noise. So always keep the tip of this histogram away from the orange and away from the red. I'm going to drop the exposure here to 1 second as a test without changing anything. Let's see if this histogram goes further down. Voila. So what just happened? Well, I'm going to expose a lot shorter now, and I'm in the orange, and it's going to get noisy because I'm on the noise floor of the camera. I want to be able to expose long enough, but not too long, so we don't wash out the object. So I'll lose my dynamic range if the gain's too high. If I increase the gain, here it's maxed out. Let's go back to the recommended, yeah, it's 100. 100, and let's go back to, let's say we'll try 30 seconds as a test. Just want to see what the histogram's going to say. At 30 seconds at gain 100, and black set it, well, you can actually click on this, you can move your arrow up, arrow down. So there's 50, there's 0. Now you can enter it by hand. Let's try, I think 5 should be enough. 5, enter. Okay, we're done. So no gain, a little bit of black, and we're coming up on 30 seconds, 15 seconds to go. And that'll pretty well conclude the smart histogram sensor analysis test. Next thing you're going to want to do, go outside, set up all your gear, focus your telescope, get it out there, and fire up the sensor analysis in, the sensor analysis you should do in the house when you're completely done. You can use the brain and say, measure my sky. Measure my sky. Tell me what you want me. Tell me what I should give me recommendations to my minimum exposure, my maximum exposure, and how long I'm going to be imaging for. And aim for max dynamic range. And when you're ready, hit apply. If I hit apply, all these numbers are going to change based on these. This is nice. You don't have to, well, copy this and copy that. Nope. Just hit the apply. There he is. There's my first 30 seconds. We're in the green. It's not too bad. So if I hit apply, there it is. 60 seconds, gain at 100. Everything else is automatically entered. And because I have version 2 of the mono hypercam, look at my temperature on my fan. 23. Guess what? It's 21 in the room. So this is actual representation of the sensor temperature without having a thermoelectric cooler installed. So that's it. That really concludes how to use the image analysis in Sharpcap Pro to give you a good gain offset setting to get dynamic range from any target, any time of the year, in any conditions. If the moon was out, those settings would have changed because it would have said, well, your sky is way too bright, so we're going to have to back off on your gain and your exposure. But if it's really, really, really dark skies, the sky brightness would not have been high. It would have been 23 or 25 or 30 or 35. And the gain would have maybe gone up to 300, 400, 500, which is just 5%. And your optimal exposure can go longer. Why? Because it's darker. So I really love this. This is like a wizard for sky sensor analysis for the hypercam and I suppose other CCDs also. So did you enjoy this? Please subscribe. Tell your friends. Hit the like button. Make a comment. And hit the little bell to receive more updates on these videos that I'm trying to do. That I've looked on YouTube all over. I don't even know if there is a smart histogram YouTube video. Well, there is one now, and I'm not saying it's perfect. I'm honest with you guys. I don't know all the statistics of these thresholds and data and gains and read noise. But what I do know is I really trust these settings because the sensor has been tested under all kinds of dark and bright situations. So we want to thank the owners and designers of the SDK of Sharpcap Pro for that. I think it's Robin, I believe. If not, I was saying the wrong person, but I think I got it right. Thank you for watching. Don't forget to subscribe, and I'll catch you guys later. I have more videos coming up. Enjoy this. Talk to you later. Bye for now.